The title of my presentation is Representative Design and Performance Analysis in Soccer. The idea is share with you how we can use a concept from psychology to improve data collection and analysis of football performance during training and competition. As you know, in the last years, the capacity to collect data from the game improved a lot. For instance, using Prozone for time motion, video and notation analysis, OptaPro for notation analysis or of technical actions, or also Video Observer, a Portuguese software for a portable and online video and notation analysis systems. We can know all or a lot of details of the game that help coaches and researchers to improve the knowledge and intervention on the game. In a quick example, the time motion analysis of the teams of Premier League games during one season revealed that players of different positions revealed different intensity on displacement. Today, it is possible to capture this data during the game and also on the training sessions to compare the requirements of the training tasks with the requirements of the game. However, no relationship was considered between this information and the tactical behavior of players, for example, or the dependence of these results with the circumstances of the game. Also, there is a lot of information about technical actions. Today, we have online all the information about the best championships in Europe that can be used to understand the game, to characterize the best teams, or to understand the evolution of the game. For example, in this table, you can see the comparison of national teams between the European Soccer Tournament in '96 and 2000. Well, a lot of information exists, is true. However, it was assumed that only consider this information, it is difficult to understand and characterize the teams and to know how the game evolves and how we can predict the results of the game based only in this analysis. So, over the last years, one of the main issues that researchers and coaches attended was the control of the physical, physiological and technical requirements of the game in comparison with the exercises used in practice sessions. The idea is to compare the performance of players and teams over the game and on the training sessions to understand the transfer of some training exercises to the game. For example, the work that I present you in this slide revealed that the 4 against 4 small-sided game played with 1 or 2 ball touches increased the high intensity running and the difficulty to perform technical actions, being more specific to match demands in comparison with the free touches, for example. Recently, some attempts are done to improve also the understanding of the tactical behavior of players and teams. Specifically, researchers are looking to the coordination process between players and teams based on players and ball displacement. For example, in this work of Gonçalves and colleagues, the analysis of the relations between centroids of defenders, midfielders and attackers showed that displacement of players near are more coordinated with their own position-specific centroids than with the other centroids. However, this coupling effect was stronger in midfield players and weaker in forwards. But despite of the increase on the knowledge regarding to the football game, some many doubts remain about what it means, what this information means, what means a player being more coupled with his own centroid than with the other centroids, and how we can use this information and how we can transfer this information for the field for coaches. In this sense, despite of the developments in collecting data and on the analysis of time motion, technical and tactical behaviors of players and teams, a question remains when we need to use the results for coach intervention. How to get meaningful information into the hands of coaches, managers and players, specifically related with tactical behavior. Thus, based on the concept of representative design proposed by Egon Brunswick, when he observed that the research developed in psychology didn't have transfer for the field, and based on some of our work, we will present you some ideas that we consider will help you to understand how performance analysis may improve coach intervention on tactical behavior of football teams. The idea of representative design is based on the assumption that practice or laboratory tasks need to maintain the perceptual variables that convey the information that players use to control their actions in specific sport performance contexts. Moreover, in a recent meta-analysis, we observed that the differences between experts and non-experts are more evident not only when was maintained the perceptual variables for action, but also when the players explore the research tasks as they do in performance environment. In general, we consider that to maintain the representativeness of the practice tasks over training sessions, we need to maintain the dependence between the players and performance context. Based on the same concept, to capture performance of players over the game, we need to capture the contextual dependence between players and game environment in order to understand how the game environment is constraining players' performance, as we can observe in these pictures. The idea is how the practice tasks environments are constraining players to perform in a specific way, and how these behaviors are transferable for the game environment, and also how we can measure players' performance by better understand the contextual dependence between players and the specific environments of performance. Based on the concept of representative design, we measure how the manipulation of practice tasks help on understanding the transfer of players' behaviors between practice tasks and game environment. For that, we used 4 passing tasks, as we can see in the picture. On the first and second conditions, the players only need to pass the ball for the player predefined. In the condition 1, the players only need to pass the ball in front. In the second condition, the players only need to pass the ball for the diagonal player. In the third and in the 4 conditions, the players need to choose to what player they can pass the ball based on the position of a second ball. In the third condition, the players can pass the ball in front or in the diagonal, and in the 4 condition, the players can pass the ball in front, in the diagonal, or in a lateral pass. In general, we increased in these situations the possibilities for action that players need to manage to perform from the condition 1 to the condition 4. The 4 conditions are compared with the futsal game, measuring the speed and variability of ball speed and also the passing accuracy. Well, the results revealed that for passing accuracy, the percentage of accuracy here decreased with the increase in the number of possibilities for action. So we have a high level of accuracy in the first and in the second condition, and we have that decreases for the fourth condition. Similar results to the match are observed between the third and the fourth conditions for the variable ball speed. In opposition to what we expected, there are no differences between conditions and the game. The speed of the ball for the different conditions and the game are quite similar, and there are no differences between these ball speed velocities. However, when we analyzed the ball speed, it revealed interesting results. With the increase on the contextual dependence with the context from the first condition, a predetermined condition, to the fourth condition, the variability of the ball speed increased, as we observed in graph A. In this plot, we can see that the values of approximate entropy increased from between conditions. The variation on ball speed is consequence of the need of players to receive the ball and pick up the possibilities for action to successfully perform. Sometimes they perform quickly, and other they need more time to adapt their movement to the movement of the other ball, as we observed in graph B for the condition 4. So in the condition 1 we have a stable pattern of ball speed, and because players need to adapt to the changes on environment, we found a very variable ball speed during the time. Thus, as consequence of this, the fourth condition was the unique that didn't reveal any differences with the match condition. Based on these results, and even without considering the defenders, we can say that increasing the number of possibilities for action and allowing players to explore the relations with the players of the same team, we increase the representative design of the practice tasks. Well, based on the same ideas, we analyzed the statistics of passing actions of a Portuguese football team in 3 games. After data collection, we observed the successful and unsuccessful passes, the places on the field where the players lose more balls, and the direction of the passes from different zones. However, with this data, we cannot identify, for example, why sometimes the same player passes the ball in one direction and in other times in different directions, for example. Thus, to improve the understanding of players' performance, we measured the contextual relations developed with opponent players to identify if different game conditions afforded different actions. Based on the concept of representative design, we analyzed players' performance considering the dependence between the players and the performance context. For that, we measured the number of opponent players that are close to the ball at the moment of ball recovering in defense. Using social network analysis systems, as we can observe in this figure, we observed that there are contextual dependence on passing actions and opponents' behavior. Thus, we can observe in this figure, when the ball carrier was surrounded by 2 or less defending players, he passed the ball to midfield players with short passes, as we can see by the blue lines. So we analyzed the ball recovered by the two wing defenders, and we try to understand the differences on passes of wing defenders after ball recovering. So we observe that when this player is surrounded by two defending players, they tend to pass the ball in a short pass to the midfielders, and in opposition, when the ball carrier was surrounded by more than two defending players, he usually passed the ball to forward players with long passes, as we can see in these red lines. Based on this information, we consider that it is possible to understand the variations on game environment on players' behavior. This information is assumed to be useful information that will help coaches to prepare their own team or to better understand the behavior of the opponent team. Well, it seems that the ideas that support the concept of representative design could be used to improve the functionality of the data collected for performance analysis. For us, the main issue is to characterize and identify the behavior settings that sustain players' and teams' performance, maintaining the perceptual variables that convey the information that players use to control their actions, and also the opportunity to explore and reach the game possibilities for action. Moreover, the variables used to capture performance need to highlight the relations that sustain players' behavior and not only their actions. For that, the identification of collective patterns of play, the sectorial and dyadic relations between players are crucial. Also, more than only understand the competition, there is a need to understand how the practice tasks used in training sessions are promoting more adapted behaviors to the game. Or saying in other manner, what is the transfer between the training and competition? It is an interesting issue that has been explored, for example, in flight simulators, comparing the activities of the pilots during the flight and on the simulators. In last years, this comparison has also been developed for physiological purposes. However, in behavioral and tactical terms, it has been neglected. Saying that, we consider that to improve the analysis of football performance, to produce more reliable and useful information for coaches, we need to explore three areas of research. Well, we consider that we need to analyze football performance, to measure and characterize patterns of play, to compare the game and the practice tasks performance, and also to understand the effect of manipulation of practice tasks. In the next slides, we will present you some examples of our research that account with referred goals. For example, in this first research, our goal was to analyze and characterize the spatial relations that sustain the defensive success in football. For that, we have evaluated 91 game sequences from 3 games, in which the ball was passed to one player inside of the defensive structure. It is one of the most important moments for defensive teams that need to reorganize around the ball to not allow the attacker team to receive or the attacker to receive or even to progress on the field. This picture is one example of a possible situation analyzed. For this is the ball carrier that passes the ball to the other attacker that is inside of the defender's structure, and this is the first defensive line, this is our second defensive line in this picture. For data analysis, we used the players' displacements over the field based on data captured by Prozone. I would like to thank you to Prozone for sharing the data with us. Using this data, we measured the distance between ball carrier and the closer defenders, the first and the second defender, the distance between the defenders, the distance between the attacker that receives the ball and the closest defender, this one. Also, to understand the position of defenders in relation to the passing trajectory, we measure the angle between the ball carrier, one of the defenders, and the ball receiver. Also, we measure the angle between ball carrier, the second defender, and the ball receiver. This angle gives us the distance or the proximity or the variation on the position of each defender in relation to ball carrier and ball receiver, or in relation to the passing line, if you want. Also, some collective variables of the teams are measured, such the ratio width between teams, in order to understand the global relation between teams that sustain the success of the attack or the defense. Our results revealed that when the ball was intercepted by one defender, all the distance between players tend to decrease, decreasing the spatial window that the attackers has to pass the ball to the other attacker, as we can see in these plots. However, the distance that decreases more is the distance between the third defender and the attacker that receives the ball, as we can see here. And this is the distance between this attacker that receives the ball and the immediate defender. We suspect that when defender player perceives that he cannot intercept the ball, or he cannot decrease his distance with the attacker to pressure the ball, he didn't decrease his distance to the defender. Instead of it, he maintains his distance to the attacker to divide possible passing lines with other attackers, and consequently to maintain the defensive equilibrium to protect the goal. Regarding to the angles, we also observed an increase on the angles between players for defensive success, meaning, in line with previous results, that the defenders are closer to the passing line when the ball was intercepted. Increasingly, the ratio width between teams revealed an increase for successful defense. The analysis of the width of attacker and defender team revealed that when the ball was intercepted, the defending team revealed lower width and the attacker higher width in comparison with successful passes for attacking team. Thus, based on our results, we can see that there are some defensive local adaptations or defensive local relations developed between players to intercept the ball, but there are also some global relations developed between all the players that sustain the defensive success. And we consider that it is really useful information for coaches. And more than evaluate the entire game, we consider that this type of research help to better understand the global and local rules that sustain teams' behavior. With these results, for example, it is possible to define for the team analyzed the preferential spatial relations that support their defensive success, so coaches can try to improve that relations over the training sessions in order to promote more adapted behaviors over the game. Well, for a comparison between the game and the training sessions, we used a formal futsal game and a training task with numerical inferiority of defending players. Using also players' displacements over the field, we calculated the relative phase between the angle of all the players and the goal over the game. The relative phase is a variable that allows us to capture the synchrony between players on the field and to identify the prevalent modes of coordination that sustain their behavior. Also, the distance between players to the geometrical center of own teams, the surface area of both teams, and the distance between geometrical center of teams are calculated. The results of relative phase, as you can see in these graphs, revealed interesting differences on the patterns of play between defending dyads, the first graph, defending ball pairs, the second one, and defending team ball relations in this third graph. As we can observe, the higher prevalent modes of coordination emerge when we analyze the inferiority numerical relation for defenders. It means that when in numerical disadvantage, the defending team tend to couple the behavior of their own players to protect the goal and not allow the attacking team to advance on the field, neglecting the relations with opponents. Also, in relation to the distance of players to geometrical center of own team and the surface area tend to decrease for an equal number of players, meaning that the team plays with the players closer to each other and occupying lower space on the field. At the end, the distances between teams tend to increase, revealing that the defending team retreats its position on the field to avoid the attacking team to reach additional space to kick at goal. Based on these results, it is possible to affirm that using numerical disadvantage can help coaches to improve defending relations. The attacking team didn't reveal any difference. Further research is needed to consider the successful or the relation between players or teams regarding to the successful of the actions. There are no works that compare the successful of actions in relation to the prevalent modes of coordination over the game. Also, based on previous research, it is also possible to measure the level of coupling between players that participate on the game. The image that I show you revealed that the stronger couplings between players are observed on the defending team. However, the coupling, for example, between D1 and D3 and between D1 and D4 revealed higher variability than the other relations. Measuring these relations, it is possible to compare what type of relations coaches are promoting during the training sessions in comparison with the game. We can see in this plot that using a cluster analysis we can observe three different groups, and distinct relations are observed between the attacker players and the defending players. Also, on the group of defending players, it is possible to observe that there are a group of players that have a stronger relations between them and other group of players that are present lower relations with their colleagues. To finish, I just want to highlight some points that need to be considered for development of future research, considering the representative design ideas for performance analysis. First, there is a need to analyze performance not only in terms of what each team and players do, but also how and why each team and players interact to achieve performance goals. Second, there is a need to analyze performance over the different behavior settings that emerge during the game. We don't need to analyze all the game, but we need to specify what we want to analyze. Also, there is a need to explore the link between specific patterns of play and outcomes of performance. It is really interesting to understand how players behave, how players interact to achieve successful performances. And at the end, there is a need to understand the effects of the manipulation of practice tasks for competitive performances.